The Tobit model is a statistical model proposed by James Tobin to describe the relationship between a non-negative dependent variable and an independent variable. The term Tobit was derived from Tobin's name by truncating and adding it by analogy with a probit model. The model supposes that there is a latent variable. This variable linearly depends on via a parameter which determines the relationship between the independent variable and the latent variable. In addition, there is a normally distributed error term to capture random influences on this relationship. The observable variable is defined to be equal to the latent variable whenever the latent variable is above 0 and 0 otherwise. Where is a latent variable? Consistency. If the relationship parameter is estimated by regressing the observed on, the resulting ordinary least squares regression estimator is inconsistent. It will yield a downwards biased estimate of the slope coefficient and an upward biased estimate of the intercept. Takeshi Amemiya has proven that the maximum likelihood estimator suggested by Tobin for this model is consistent. Interpretation. The coefficient should not be interpreted as the effect of on, as one would with a linear regression model. This is a common error. Instead, it should be interpreted as the combination of the change in of those above the limit, weighted by the probability of being above the limit, and the change in the probability of being above the limit, weighted by the expected value of if above. Variations of the Tobit model. Variations of the Tobit model can be produced by changing where and when censoring occurs. Amemiya classifies these variations into 5 categories, where Tobit type I stands for the first model described above. Schindler provides a general formula to obtain consistent likelihood estimators for these and other variations of the Tobit model. Type I. The Tobit model is a special case of a censored regression model, because the latent variable cannot always be observed while the independent variable is observable. A common variation of the Tobit model is censoring at a value different from 0. Another example is censoring of values above. Yet another model results when is censored from above and below at the same time. The rest of the models will be presented as being bounded from below at 0, though this can be generalized as we have done for type I. Type II Tobit models introduce a second latent variable. Heckman falls into the type II Tobit. In type I Tobit, the latent variable absorbs both the process of participation and outcome of interest. Type II Tobit allows the process of participation selection and the process of outcome to be independent, conditional on X. Type III introduces a second observed-dependent variable. The Heckman model falls into this type. Type IV introduces a third observed-dependent variable and a third latent variable. Type V, similar to Type II, in Type V we only observe the sign of the likelihood function. Below are the likelihood and log likelihood functions for a type I Tobit. This is a Tobit that is censored from below at when the latent variable. In writing out the likelihood function, we first define an indicator function where. Next, we mean to be the standard normal cumulative distribution function and to be the standard normal probability density function. For a dataset with n observations, the likelihood function for a type I Tobit is, and the log likelihood is given by. See also, generalized Tobit, limited dependent variable, truncated regression model, references. Further reading, Amemiya, Takeshi. Regression analysis when the dependent variable is truncated normal. Econometrica 41, 997 €1016. doi, 10.2307/1914031. JSTORA 1914031. Amemiya, Takeshi. Tobit Models, A Survey. Journal of Econometrics 24, 3 €61 doi, 10.1016/0304-4076, 84, 90074-5. Amemiya, Takeshi. Advanced Econometrics. Oxford, Basil Blackwell. ISBN A0-631-13345-3. Schindler, Wendelin. Likelihood estimation for censored random vectors. Econometric Reviews 24, 195 euro 217 doi, 10.1081 etc. 20006792 Tobin, James. Estimation of relationships for limited dependent variables. Econometrica 26, 24 euro 36 doi, 10.23077/1907382. JSTORA 1907382A